Okay, so this is the last part of the word problems that we're going to do today. And I'm not going to probably get through all 7, but I'll go through as many as I can, and I'll save the 7th one for us to do together, just so that I can mention a couple things. So if you look at this first problem, we're now talking about real life problems, things that you might do just mentally on your own in your mind, and you'd say, where are we going to use math in the real life? A lot of that is because you do some of the things in your head. So if I read through this problem, it says a ticket to the movie costs $7. You have $21. How many tickets can you buy? So the first thing to do is to look at what is it that I'm looking to find. I'm looking at how many tickets can I buy. So I'm going to choose my variable to represent the number of tickets. And I like to choose X, but you can use whatever letter you want. From there, what you have to remember is the cost formula. Now the cost formula says how much does something cost times how much do I buy, how many tickets do I buy, equals the total cost. And that's a formula that you want to hold on to. So if I look at this problem, how much do the tickets cost? The tickets cost $7 times, I don't know how many I can get, but that's what I'm looking to find, and I have a total of $21 to spend. Now again, if we follow order of operations, you can see we have our variable term on one side, numerical term on the other, or our constant term. So all I have to do here is divide, and notice we get this number 3. Now many of you had this a long time ago. You just knew what it was. But this is the equation that I need you to make sure that you consider, especially the cost equation as we get to more complex examples. Notice also that the answer that I got is a natural number. I need that natural number because I can't buy a -3 tickets, and I can't buy 2.5 tickets. I can only buy a natural number of tickets. So my answer to this problem is I can buy 3 tickets. The next real-life example we see is actually one of the preferred ones, and I really need you to make sure that you understand this type of problem. And you're going to see 2 examples that fall under this category, even though they look a little bit different. So this problem says the bill from your plumber was $134. The cost for labor was $32 per hour. The cost for materials is $46. How many hours did the plumber work? So again, look to the question, how many hours did the plumber work, and choose your variable. X equals the number of hours the plumber worked. So then from there, as you're looking to build your equation to start that out, you know that the total bill from the plumber was $134. So that means it's an equal to 134. You also know that the plumber makes $32 per hour. So as he looks at this, or she looks at this for the plumber, it means that if I worked 1 hour, the plumber made for labor $32. 2 hours would be 64, and so on. So what we're looking for here is that that's a changing rate, and that's what's going to be attached to my X. It's $32 for how many hours he works. Cost times number. But now added to this, we have this other piece of information which says the cost of materials was $46. Now that cost of materials is set. And because it's set, it's that constant term that's added to the equation. So now that we have an equation, what's set was the $46 and 32x, how much he makes for every hour or she works. We're now going to solve our equation. So I'm just going to rewrite this 46 that I circled. And I'm going to box my variable term, and I'm going to subtract over my $46. Now, if you're a person who mentally does this in your head, you might have already subtracted what was set from the total bill because you knew that that's not going to change. And that left us with $88, which formatted what was it that we got, or the plumber got, for his labor. So last, if I divide, now that I have variable term and constant terms on opposite side, you'll notice that we end up with 2.75. Now a couple things that you need to remember. X is the number of hours. So the question is, can I work part of an hour? And the answer is yes. In fact, 2.75 is the same thing as 2 3/4 hours that the plumber is working, or 2 hours and 45 minutes. I'm okay with you keeping it as 2 3/4 hour, but I do want you to know what that really means. So the next example I'd like you to do is I'd like you to realize that this example or word problem is very similar to the previous problem that we did. Only difference is that it's all represented by money, and specifically here, salary and commission of a salesperson. So kind of realize here that the base salary is like your set, and that the commission is what fluctuates based on the total sales that the plumber has. I'd like you to pause the video, try this on your own, because this will be the last example I'm going to give you for this lesson. Okay, so let's look at this problem. It says a salesperson at a car dealership has a base salary of $25,000 per year and earns a 5% commission yearly on total sales. How much must the salesperson sell to earn $50,000 in 1 year? So the question is saying, how much must the salesperson sell? So our X equals the total sales. That's what I don't know. But what I do know here specifically is that that salesperson wants to make $50,000 in 1 year. And I also know that the base salary is $25,000. So that's what's set and doesn't change. The only flexible rate here that we have is that the salesperson earns a 5% commission on total sales. So if X is total sales, what we then have to do is say, how can I write 5% as a decimal? And the answer to that is 0.05. And so our equation becomes 5% or 0.05 of total sales, which is our unknown, plus the base salary of $25,000 equals $50,000. So as we try to solve this equation, some of you might have written your equation to already subtract out the base salary. And so you might have a starting equation of 0.05 equals 25,000. And as you do that, what I want you just to kind of know is that that's okay with me. But it's a good thing to show $50,000, what I wanted to end up, minus 25. So our last step is to divide by 0.05, and you should have ended up with 500,000. So if X represents for us the total sales, that means the salesperson has to sell $500,000 in total sales in order for him or her to make $50,000 in 1 year. I'd like you to now just kind of hold on to this information, bring your books to class tomorrow, and we're going to build off from this.